Hello guys, in part 2 in lesson 10.6. After we are talking about some concepts of the probability, let's revise what we are talking about. We talked about the experiment, the sample space and event, the probability, and we said the probability it's a number from 0 to 1, the theoretical probability, and this is the rule of the theoretical probability. Now, let's move to the main concept of our lesson today, which is the geometric probability. What is the geometric probability? The geometric probability is a probability of an event is based on a ratio of geometric measures, such as what? Geometric measures such as what? Such as length, area, or measures. Okay, or length. Okay, this is the meaning of the geometric probability. Okay, طيب, when we can use the geometric probability? The geometric probability is used when an experiment has an infinite number of outcomes. If you have an infinite number of outcomes, and we said that the outcomes are the results of the experiment. If you have an infinite number of the outcomes, so you can use the geometric probability. طيب. So now we have three examples or three models for the geometric probability are shown here: length, angle measure, and area. Let's see. What is the sample space in each model? What is the event in each model? And what is the probability in each model? Let's start by the length. For example, we have this line segment. It's line segment AD, and points B and C lie on the segments. Now I want to know what is the sample space. The sample space here in this line segment is all points on the segment. All points on the segment AD. This is the sample space. Type. What about the event? What about the event here? The event here we can talk about مثلا all point on BC, or all point on CD, or all points on AB, or all points on AC. Okay, select any part, any set of the sample space. So again, this is the difference between the sample space and the event. The sample space is all points on the experiment, but the event is any set of the experiment. So let's talk, for example, about مثلا all points on مثلا, let's talk about BC. All points on BC. So now, what is the probability? The probability. So B here equal, we said the probability is what? Let's revise again. The number of outcomes in the event, over the number of all possible outcomes. طيب, let's back to our example. All outcomes in the event, in the event which is, all points in the event which is point on BC over all possible outcomes, number of all possible outcomes in the sample space, all possible outcomes in sample space, what? All points on AD. So this is the probability if we are talking about the length. Okay, now let's talk about angles. What about angles here? In this figure, let's shade this part, for example. So we're going to talk about this angle. What is the sample space now? All points on the circle. The whole figure here now is circle. So the sample space here is all points on the circle. Fine. What about the event? The event here is, whether I'm talking about angle measure, so of course the event will be all point in the shaded region. All points in the shaded region. All points in the shaded region. This is the event. So can you figure up the probability? The probability will be P equals we said what all the points on the shaded region. So we can talk here about the measure of the angle. The measure of the angle over all outcomes, all possible outcomes in the sample space, all points on the circle, all points on the circle, which is how many degrees? Do you remember the circle? Yeah, 360 degrees. Well, now let's talk about